And it's going. Make sure you speak nice and loud. You may want to speak into that microphone.
All right, welcome everybody. We're doing the ISSA Kentucky workshop for November. We're going to be looking at RESTful web service testing. So for the lab environment, we have Matilda running as a website. In this case, I'm running on localhost, but you could run it on a virtual machine or across the network or whatever. And we're going to be using Firefox initially to browse to this web service, just to generate HTTP requests. And we're going to primarily use the Burp Suite free edition to do the testing. So in Firefox, off the Matilda's front page, I'm going to go to Web Services, and then REST, and then either SQL Injection or username enumeration. It turns out it's the same web service either way, so it doesn't matter which path you take. And this is the new and improved help page. This hasn't been released to SourceForge yet, but I'll release it probably tonight. So it still has a help page on there right now. It's just kind of harder to read. It's not formatted. So when you browse to this web service, it's pretty typical of a RESTful web service. They have a tendency to show you some kind of help documentation if you browse to the service without any parameters using a regular GET. And this one's pretty similar. It tells you that the web service has 4 methods and it has 4 parameters. We'll talk more about methods and parameters here in just a second. And then by default, it just dumps out a list of accounts that are in the system. So the way that the RESTful web services work as opposed to the SOAP-based services is the RESTful services actually use the HTTP protocol to communicate which method is to be called. So we'll get a regular request going here and capture it. So in the proxy, we're going to turn the intercept on. And if we look in options, we can see the proxy is listening on localhost on port 8080. We look at Firefox's properties, oops, not the menu properties, but the actual edit preferences properties. We go into network and settings, we'll see that Firefox is proxying through localhost on 8080, so it's sending its traffic through Burp Suite, and then Burp Suite sending it onto the website. So we'll go ahead and make a request for this page again. Go to the Intercept tab under the Proxy tab, and we'll see this request. And it's just a regular GET request. There's nothing unusual about that. We'll go ahead and forward that on. And we get the help page back that we've intercepted, and we'll forward that back onto Firefox. And it displays the help page. However, since this is a RESTful service, it also allows you to send other kinds of HTTP methods, post, put, and delete. So for the exact same URL, we can actually change which method gets called on the application by changing the HTTP method that we use to call. In a SOAP-based service, it would be more likely that we may call the same URL, but we would have to send different XML requests to call different methods. So in Burp Suite, I'm going to turn the intercept back on, and I want to start to test some of these methods. In fact, it'd be nice to know, especially if this documentation wasn't here, what methods does the RESTful service support? It could support more methods that are actually listed in the documentation, or it could be that you don't have documentation. In some cases, the customer that you're testing for won't actually give you the requests to make. That's actually kind of rare. Normally, if they want you to do a good test, they're going to tell you everything you need to know to make legitimate requests. But if it's a true black box test, they won't give you anything except for the URL. So let's start by figuring that out. Okay, with the again with the intercept on, we'll need to capture a legitimate request to start with. So I'm just going to request this page over again. And I'm going to send this request over to the intruder. And I'm going to release this intercepted request to go on about its way, because we have a copy of it over here in the intruder. You can right-click anywhere in the field to send requests from the tab that you're currently in, such as proxy, over to another tab, such as repeater or intruder in this case. The burst suite automatically marks the fields that it's going to fuzz with these squiggly characters here that have they have a real name, but it escapes me at the moment. I'm going to clear those because I don't actually want to fuzz the PHP session ID or the show hints. I want to fuzz this HTTP request method to figure out what other methods the web service might honor. So I'm going to highlight get, add the marks around get, and that tells the intruder that it's going to fuzz that particular value. You can mark more than one position. So for example, if we wanted to fuzz the method and also save the extension of the file, you could add both of these. And then an intruder would take turns fuzzing first this field, holding this one constant, and then vice versa. You can change that behavior by changing the attack type. For example, if you wanted to fuzz all the positions at the same time, or you wanted to use two different lists of injections or what have you. So over in the payloads, I'm going to load from a file the methods that I want to test. You can type them in here and add them one at a time, but it's easier just to have a file and load them in from that. To make the file, I just used Nano to type it in, so it wasn't anything big there. But you can get the files themselves from projects like Laudanum, which has shells that are already ready to go, ready to inject. And you can get the basic fuzzing values from different projects on SourceForge for free, or you can just type your own. All right, so what we're going to do is we're going to send get into that field, that position, I should say. And then post, put delete, and turn. And we're going to look at the responses that come back and compare them to one another. It's important to start out with a known good request. So that's why we're using the request that brought us back to the help page, because we know exactly what response ought to be brought back by the web server for a good request. We can even test that ahead of time by sending this over to repeater and repeating this request to verify that that help page that we saw earlier comes back. So this is a known good request, and it's about 1960 characters in length. The length is at the bottom corner. All right, we have our payloads ready. Go ahead and hit start. Okay, so the test is over. We'll sort by length. This test is small enough we can actually look at these one at a time. So we used the head method, which wasn't actually documented, but it did work. So this is a valid HTTP method to use on this service. Trace is not allowed. You can see down here it says 405 method not allowed was the response. Option is through an exception. So that's pretty interesting because this is an application exception. That means in the case of the trace, you can see that the error message actually came back from Apache, so from the web server. But in the case of the options, the error message came back from PHP, the application server. It made it past the web server. Just interesting to note those kinds of details. When we sent in the post method, we got a PHP exception, but the message is post parameter username is required. So it looks like this method actually does work. So far we have head and post are working well. If we try put, we'll get the same error message that we got with post, delete, same error message. Our baseline request was the get with no parameters, and of course it worked. And then here we just sent in get again, so it's a duplicate of the baseline request. So for our testing, we're going to test get, delete, put, and post. The head request is probably not too interesting because all it's really verifying is that the URL is correct. If you're actually fuzzing the web server itself, which we're not doing today, we're fuzzing the application, then you would want to go ahead and include this in your test. So we're going to go ahead and close this window. Go back to this page. So we can see for a GET request, it's either going to display all the usernames like it's doing down here at the bottom, or it's going to display some more information about a particular username, but we would have to get that username correct. And we need to send in the username as a URL parameter, and it's important to pay attention that it's a URL parameter, it's not a post parameter, it's not a cookie. Great. So to test this, I made a file just real quick of actually of people that I just all sitting around the room. So let's see, username, fuzzing values. So these are a bunch of names of people I saw, and some ones that I just made up. We'll just try to send all these in and see if any of these are valid usernames. And of course, if this were a real test against a real site, we would use a dictionary and then probably Cool, the CEWL, to scrape words off of the target website and gather a list of potential usernames. And then we could use username enumerators that do things like take first name dot last name and put them together, first initial, last name, put them together. They automatically mangle those names for you. And there's a bunch of manglers available. I think the one in Metasploit's pretty good. That works well. And there's others as well. I think ReconNG has a good mangler in it too, if I'm not mistaken.
Yeah, I don't look. I was people talking about doing permutations that go through those. A guy named Rick Redmond who gave a talk at DerbyCon about how people go for certain patterns on their passwords, and you can kind of quickly crack things based on those patterns.
Mm-hmm. Yep. Yeah, I think username followed by some series of numbers is probably a good guess.
Company name or season was another.
Company name is good. Yeah. Site name. It's good.
I like the Dan Kaminsky password generator. I'll tell you later.
Okay. So just following the instructions. Oh, look at that. Firefox is cheating. Remembers everything. So we had to say that it's going to be a URL query parameter. So, you know, question mark username equals and then whatever. We'll capture that in invert again. Intercepts on. Okay, so we have a URL parameter username equals whatever. We'll send that over to the repeater and see if it works. Or we can just release the request and look at Firefox. And actually, it did work. It says user whatever doesn't exist. So while that's not the response that we necessarily wanted, it is a valid response. So now we have a valid baseline response to compare other responses against. Repeat that in the repeater. And we know it works, and we'll send it over to the intruder. Now technically you could sit here in the repeater and, you know, type usernames in, I suppose, but you can already see the intruder is a lot faster about cycling through things quickly. So we're going to clear out this list, or maybe not, maybe we just add on to it, maybe you valid username as post, but I'm just going to clear it out. And then load the usernames that we typed in. For the position, I'm going to clear the method. Let's see. I think I might have jumped into a different request, so let me do this. Username equals, and we said whatever was a valid request. and I want to put the marks around the whatever so that we send the payload into that position. Okay, we'll let that run. Does anybody have any questions while we let this enumerate to these usernames? One of the first things I usually do while the test is running is I just go ahead and sort by length. Not always, but typically if you see a big difference, there's a boundary right here where the difference in length goes from being 0 or 1 to all of a sudden being like about an extra 33 characters more. Anytime you see big jumps like that, it usually means that there's something interesting about that boundary between those two responses. So when you sort by length, it doesn't necessarily pay to check every one of these responses, but anytime you see a big change, check the two that are around that boundary. So if we check the baseline response, switch over to the response tab, we just see whatever doesn't exist. And probably these are all pretty similar because they're the same size. We jumped at 425, and all of a sudden we have a different response. This is a very small test, so we can see in this case that the account Kevin is a legitimate username. And then there's a few others that we could cycle through just manually. Typically in a real test, it's not going to be a good idea to try to do things manually. Over in the options, if you're looking for patterns, if we go down to the grep area here, we can bring up one of the responses. And let's do this. Let's go back to results. I think if we highlight it, it'll bring it up over here. This isn't really the response I'm looking for. It's the one that has the has one of those valid usernames in it. If it won't cooperate, let's do it manually. So I'll say start after the expression. The results accounts the beginning of that expression we were looking for. See if we can get this to work. Okay, so there's a new column added to the results screen, the first tab, and it's pulling back the information that we're grepping for over in the options tab. And then if we sort by that information, we can group together the responses that had a match. So if you had several tens of thousands of things to sift through, this is an easier way to group things together that are interesting to you. So we can see Kevin, John, Jeremy, Dave, and Adrian were all valid usernames, and whatever all these other ones were weren't valid. So now we got some usernames. So just as a note, recently in Matilda, I added username enumeration to all of the anything that has anything to do with user accounts or logins. So if you go to the web services, there's also a SOAP service that does username enumeration. And then if you go to the login page, it now does username enumeration as well, which actually was a bit of a trick because trying to get it to do username enumeration and also SQL injection at the exact same time took a little thought. It's actually hard for once to write vulnerable code. It's usually not the case. So you can practice that on any of those pages. We're going to go ahead and close this out. So we have this valid request over here, and if we change that to, say, Adrian, it should pull back a legitimate account. At least that's what the test indicated. And there's the valid account. So now instead of just having a list of usernames, we have a little more information. We have the username and then the signature of the user. But that's still not necessarily all the information that we get to get out of here. So we're going to test this username field a little bit more and try to cause an error on purpose. See if the error can give us any more information about how this method works. And keep in mind, we're still looking at just the get method. We still got 3 more methods to go. So we would repeat this process that we're doing now. Circle back around, check post, put, and delete. And it's going to be pretty much the same testing. Anybody that's tested websites at all, you're probably thinking that this is the exact same thing you would do with a normal web page, with the exception of instead of getting back JSON, you can get back HTML, and that's correct. It's kind of the point of all this is to show that in testing web services, in a lot of ways, we're really just doing the exact same things we've been doing for a long time now, but applying them in a slightly different way. I'm going to send this over to the intruder so we can cycle through the fuzzing values a little bit quicker. We will clear out these fields down here. We don't want to iterate over those or fuzz those. We're just going to fuzz the username field. But this time in the payloads, I'm going to load a file of characters I made. And so basically what I did is I took just a quick Python script and printed out all the characters 0 through 127. And then I went back into the file and I deleted out the letters and the numbers, lowercase and uppercase. Because it appears that the valid values for the username field would be letters and numbers. That's legitimate. So I don't really want to test those. QA's probably already covered that pretty well. I'm using all the other characters that came out of that exercise. That's usually a good place to start for security testing, is figure out whatever the QA department did and then do everything else. Because chances are they didn't try anything that they didn't think would work. That's kind of the problem with modern QA, actually. Okay, so we'll go, actually I already put a stay in here, and I think we were just about ready. Clear this attack out. Got the position highlighted, we have the payloads ready to go. And this time in the options, let's look for some of these values in the grep match. Let's see, so we'll remove some of these. Stack is usually pretty good. I'm going to add MySQL. We'll start. I'll go ahead and sort by the length again and look for those boundaries. So the payloads, it appears blank. It's just that those are non-printable characters. If you think about ASCII 0 through 127, you got like bell and alert or whatever those funny ones are, like 4, 5, 6, 7. And then as you get up into the bigger ones, so here we see like single quote is visible. It's hard to see, but it's there. You may have noticed that the intruder in the free edition is Throttle. It slows down the more things it fuzzes. So if you're using the free edition, you want to keep the fuzzing values pretty tight. If you get the pro edition, not only does it become unthrottled, but it goes very fast too. All right, so there's a big difference in length between these values down here and this value up here. So if we look down here, it's just a whole bunch of user whatever doesn't exist. And then when we hit the baseline request, then we got the record that we expected to get back, the one we started with. And when we jump up to the one that has a big difference, we notice there's an exception. And in this case, it's a really good exception from our point of view because it gives away all kinds of information about the query. So we see the query right here, actually. Oops. And if you highlight something and send it to another tab, it'll just sit in the highlighted part. So we're going to send that stuff over here to the decoder because there's a bunch of HTML encoded stuff there. Okay, so here, up to about that point, we can see the query itself. This is going to make testing for SQL injection a lot easier. And it looks like at least one of the interpreters that's sitting behind this site obviously must be a database. So if we were to see some errors that look like operating system errors or LDAP errors or email errors or FTP errors, we would change strategies a little bit and maybe try to fuzz things that would mean something to those types of interpreters. But in this case, we have SQL. So we'll go ahead and continue on that thread. Okay, back in the repeater, let's repeat that. And we'll send in the single quote that we found from the other test. Get the same exception back. So at this point, we got a valid username and we have a valid error message that can tell us some information. And we'll go ahead and try some SQL injection. So in the case of the get, it doesn't really matter much that we don't know like the user's password or anything because we don't need it to get the service to work. But we did notice that when the valid response comes back, that it's not telling us very much information about the user. So there's probably more fields in that table than just those two fields. So we may be able to use SQL injection to coax the other fields out. We knew from looking at the query over in the decoder that our payload's landing right here inside this username field. We injected that single quote to get the error in the first place. So we can just think of this as our injection point right here. Then we could go through the exercise of figuring out how to make a syntactically correct query to go along with all this. And come back over here to the repeater and get that put in there. But it looks like we just need to deal with the character field, so it should be pretty straightforward to use like a union attack. I know this is a valid query. It came out of the system. Okay, we'll give this a try. If it doesn't work, we'll try something else. So I'm going to try adding in passwords. I think one problem is the database query is selecting two fields and we're only selecting one. And then also, it could be that some of this needs to be encoded. So if we send this over to the decoder, we can encode it as a URL and see if that helps. Oops. That'll help the payload get past the any kind of interpreters. Okay, it says the use select statement has a different number of columns, and so guessing username password wasn't a very good guess, but it turns out that encoding the payload was a good idea. So maybe we can try to do something like add some nulls just to pad out the number of columns that we're trying to select from. Okay, same error, go back to the decoder, try. Nulls make a good pad because the null data type matches any data type, so it doesn't really matter if the third column is, you know, an integer or a varchar or whatever. The null, generally speaking, matches everything. And try another one. Of course, we should probably use the intruder to add nulls every time until it gets it right. So that would be a lot quicker. And it can do that. It can add characters each iteration. Wow, there's a lot of fields in this thing. I think what it's trying to tell me is I should have done this, figured out what the answer to the demo was before getting up here. All right, so let's see. Well, that's just a ton. So let's see, let's try one more time. We're on the right track. All right, well, let's cheat a little bit. Let's go back and look at the error message a little bit closer. I might have missed something because I think it told us, oh, here it is, okay. Yeah, kind of a dumb moment. So it told us that there was one field selected. So I could have saved us all a lot of time actually by just paying more attention to what the exception messages look like. See if this works. Select username, let's see. Okay, so I give up. But the idea would have been to use the union attack. Unfortunately, for time's sake, we'll have to move on. We could have tried to dump, I guess, all the accounts. Using just regular old SQL injection. Let's see here. Or maybe not. Instead of having to go to the coder, you can also say URL encoded to type, which is kind of handy. So you can do like you can type in whatever and it'll encode it up here in the field as you go. That way you don't have to go back to the coder tab. So, well, this injection worked because what it ended up doing was dumping out all the users and all their signatures. But since we're only selecting those two fields, we didn't get the passwords, and for that we needed the union. And that's where we were trying this. Try to select like password from accounts. So we'll give up on that thread. All right, moving on. So we get the next method was the put, post, and delete. So let's try the delete method. And we had a valid account. It was the Adrian account. So we'll try delete and see what happens. And we got an exception. And it says post parameter username is required. We actually sent username in, but we sent it in as a get parameter. And there's no post parameters at all if you look down here in the body. So that's part of the problem there. So we'll change that. To do that, I'm just going to right click and say change the request method. That'll switch it over to a get. Then I'm going to change it again. And this time it'll switch it to a post. It'll move the parameter down as a valid post parameter. It'll put the requisite space and have the right spacing and all that kind of stuff. And then we can change this post back to delete the way we wanted it. There you go. Okay, and it says post parameter password is required. So in order to be able to delete an account, at least using this method, we have to not only know the username, but also password as well. Maybe we don't. So we can try something else. We don't actually know the password. So we got URL encoded type selected. Let's see if this method has the same vulnerability that the get method has. And it says host parameter is required. So it looks like if we don't send in that password parameter, at least with some kind of value, we're never going to get any further. So let's go ahead and send that in. So I'm going to turn off the URL encoded type because I need the ampersand to be an actual ampersand and not encoded. And then the password is going to be whatever because we don't know what it is.
At this point, I don't even know what it is.
So this is a better result. We got the could not authenticate account Adrian, the password is incorrect. So we made it past the first hurdle. Now we'll go back and try to generate the SQL error message with the single quote. Okay, and we did. So now we know that this other method, delete, is vulnerable to the SQL injection also. All right, now let's try to figure out if we can do the SQL injection on the username field instead of the password field. Okay. And it looks like it's vulnerable too, so it doesn't really matter which parameter we pick. So we're already on the username field, so I'm going to turn the URL encoded type back on. The reason that I'm toggling that on and off is this ampersand here is a separator between the input parameters. That's part of the interpreted code that the web server is going to use to know the one parameter is in and the other one started. If you encode that, then the web server is going to think that that ampersand is data, because that's what encoding does. And therefore, it would never parse your parameters correctly. So you actually have to be pretty careful about encoding your input data, but don't encode all your entire input. Like, don't just select everything and send it over to the decoder, because that's not going to work. You're going to make it appear as if everything is data and there's nothing to do, there's no work to do for the web server. So, all right, can we get Adrian's account deleted without knowing Adrian's password? So we need to make a valid SQL statement that will be true even if we don't get the password right. So if we were to say Adrian or something that's true, like 98 equals 98, and then I'm going to put an or and that extra quote there, because we're going to leave that closing quote that was put there by the application. We're going to leave that hanging. So that was that closing quote that we looked at over here in the decoder earlier. So if we say decode has HTML. So we don't want to leave the application's single quote hanging. That's why I added that one at the end. It says we have an error in the syntax. And it looks like there's like 2 quotes there. So see if we can fix that. Let's try to unencode it and see what happens. Oh. You can see my mistakes a lot easier when they're not encoded. So what was happening was I was typing in like 7 equals 7 equals instead of just 1 equal sign. So in this case, it says it deleted the account, and to verify that, we can go back to one of the get ones that worked earlier and say username question mark username equals Adrian. And before this returned the request, but now it says the account doesn't exist. So that can be a pretty handy attack for someone to be able to target a particular record in the database without actually damaging the rest of the database. And in that case, SQL injection was not know the password. So we've actually discovered 2 different vulnerabilities testing the delete and get method. On the get, we found a way to enumerate the usernames. That was one vulnerability. And then we found that same vulnerability on the help page. If you remember, the application had a default page where it just dumped the usernames out. And then we found SQL injection in a couple of different methods and used one of them to delete the account, to delete a particular account. So we could actually probably delete all the accounts too, I would imagine. We would work through this same process to test the post and the put. The difference between those 2 is, I usually get these backwards, but I think the put is the one that you can insert an account, but if the account doesn't exist, then it will update the existing account for you. And the other one, it'll update the account, but it won't insert a new one if the account already exists. It'll just tell you it already exists and it can't put the account in the system. So, all right, so that's in a nutshell how to test the RESTful type web services using Burp Suite in 44 minutes flat. So, does anybody have any questions? We have a couple of minutes left. Adrian, do you want your account back?
Sure.
Okay. So we'll reset the database, and that'll fix any damage that was done during the demo. So when you're in Matilda and you inevitably will end up destroying something, just come back after and hit reset DB, and it'll put it all back the way it was. So it's been restored. All right. Well, thanks everybody.